We'll look in more detail at uses of nuclear radiation in Lesson 6 and radiation health effects and risks in Lesson 7. But here are some general principles to do with half-life. We know of lots of different isotopes with a wide variety of half-lives, so we can usually select one with a half-life we need. If the radioactive source is going to be introduced directly into the environment, particularly as a liquid, for example as a tracer, or injected into someone for medical reasons, then you generally want a fairly short half-life, somewhere from hours to days. This means the source ends up with negligible radioactivity quite quickly. Some machines, like smoke detectors and thickness gauges, rely on having a steady flow of radiation for months or years. This means having a long half-life, because by definition, a long half-life means the radioactivity doesn't change very much from day to day. A long half-life is fine because the isotope is a solid and contained within the machine and isn't intended to be set free into the environment. Half-lives of tens to hundreds of years are common for these kind of jobs. The challenge with using an isotope with a short half-life is you can't keep a store of it. An isotope decays continuously. You can't just switch it on and off. A PET scanner, for example, helps doctors see how a patient's organs are working. It involves injecting the patient with an isotope that has a half-life of under 2 hours. The isotope needs to be made in the hospital or very nearby. It involves an expensive and complex machine called a cyclotron, which forces an extra proton into a normal nucleus at very high speed to make it temporarily radioactive. For risk and half-life, we need to remember that long half-life means low radioactivity. Something can only be radioactive for a long time because its nuclei decay very slowly. It's common for people, and some exam questions, to worry about the risk of very long half-life waste from nuclear power plants. If you're worried about getting wet, then the radiation from long-lived waste is more like fog than a thunderstorm. We're surrounded by vast quantities of natural radioactive isotopes that have an incredibly long half-life. Uranium-238 is an alpha emitter with a half-life of 4.5 billion years. In the top 10 metres of UK soil and rock, there's about 5 million tonnes. Potassium-40 is a high-energy beta and gamma emitter. It has a half-life of 1.25 billion years. And in the top 10 metres of UK soil and rock, there's about 1 billion tonnes. All of life on Earth has evolved with the radiation from these natural radioactive isotopes. Short half-lives are like a heavy shower, very radioactive, but it's easy to wait them out. The most hazardous half-lives are actually about 30 years. These are like persistent rain. They're significantly radioactive for the length of a human lifetime.